Nicholas comes to us from America. He attended Binghamton University and Hunter College. His specialty is math, and he'll be working with all the groups during this seminar. I know you'll appreciate the time you'll spend with him. Next we have Mr. Brian Hodge. Mr. Hodge comes to us from New Zealand. He is currently teaching English at Mongkut University in Bangkok, Thonburi to be precise, English. Again, I think you'll enjoy the time you spend with him. Mr. Alan Sutherland. Mr. Sutherland has 30 years of teaching experience in Thailand. He is currently teaching at the Satit School within the Srinakan University in Bangkok. He's a science teacher and an English teacher, and he's also teaching at AUA. Has taught there for many years. I'm sure you'll appreciate him as well. Mr. Jeffrey Kastner. Mr. Kastner is the supervisor of the teacher training department at AUA. He comes to us from Milwaukee, Wisconsin in the United States, where he attended university and has also taught in Thailand for many years. I'm sure that you will appreciate the time you spend with him. Finally, we have Dr. Michael Kelly, the Director of Courses at AUA Thailand. While he's new to Thailand, he has extensive experience both in America and abroad. He comes to us from Indonesia. He's also spent time in Japan. And I hope you'll welcome him. Okay, guys, I'm going to turn it over to you. Dr. Kelly has a few words for us.
Thank you, Jeff. Hi, guys. Welcome. Thanks for coming. My name is Nick. So, before we start the break, I just want to have you guys get to know each other a little bit so we can speak to each other more easily throughout the lesson. So I guess I'll start then. My name is Nick. I currently teach in Bangkok at the AUA Chamchuri branch, teaching ESL to various students. Typical classroom has about 15 students, and the ages range from 15 to 70 years old in the classroom. A little bit about me. I am from New York City. I enjoy learning Thai, playing Dota, video game, and capoeira is my favorite sport. We're going to be talking a little bit about gambling today and probability. So I guess I'll just tell you a short story about my experience with gambling. When I was 22, I went to Las Vegas for my birthday, my 22nd birthday. And I sat down at the high rollers table. I think the minimum bet was $5, and that was the bet that I placed. But in the hotel I was staying at, I didn't know this, but everyone who gambles receives free drinks. Of course, I was 22, I didn't have a lot of money, and I didn't want to buy any drinks. So when I sat down at the table, and a beautiful young woman in a bikini came up to me and said, "Hello, sir, would you like something to drink?" I said, "No, get away from me." And she said, "Okay," and she walked away. And then I passed up my only chance to get a free drink, and I lost $30. So that's my story about gambling. Now I would like you guys to tell each other a little bit about yourselves and maybe some story, any experience you might have with playing games or gambling. How about, since we have these chairs facing one direction, maybe we could have every other table turn around to face the table behind you. So if you guys could please turn your chairs around to face these guys. And we'll have a big group discussion there by yourself. You guys, please turn your chairs around. And you guys, please turn your chairs around to face. Yes, thank you.
It should be four cards. I should draw one and show one. No, I have already. Yeah, I can show you
You gotta keep in mind what cards have been put down, and you gotta read them.
That's why you should.
Sometimes you have the last card in minimize. Make use of this. You have the teacher's card. Well, I can show it to you because the
Kings 13, ace is 1, and the rest is face value, right? Okay, so I have, so I told that x plus 2, x minus 3, x plus 3, plus 4, and x plus 6.
Why don't we just talk about this number for a second? What does the top number represent? The number of kings in the deck, that's right. But what are the kings? How can we make that more general? What if it was aces? What if it was twos? Sorry? The number of desired outcomes. Yeah. Right. The top number represents the number of desired outcomes, the things that we're interested in or the things that we want to happen. And how about the bottom number? Possible outcomes, right? Okay. And this gives us our formula in a little more easily understandable format. You can see up on the screen, it gives the general formula as the P of an E, the probability of an event occurring equals the number of favorable outcomes divided by the number of possible outcomes. Okay, in our example, that's 4 over 52, which simplifies to 1 over 13. Okay, so we have a vocabulary now that we need to know in order to progress with the lesson. An outcome is the result of a single trial of process involving chance called a probability experiment. What kind of probability experiment do you guys know? Sir? Flipping a coin. Yeah, okay. What kind of probability experiment is that? What are the possible outcomes? Right, there's 2 outcomes. Heads or tails. Or a probability experiment could be like the one we just did. You have 52 cards, you take one randomly from the top of the deck, there are 52 possible outcomes. So, sometimes we're more interested in the possible outcomes than we are in the desired outcomes. To look at the possible outcomes, we use something called a sample space. A sample space is the set of all possible outcomes. And there's an example here at the bottom. Consider how many ways can you arrange the king of hearts, the king of clubs, and the king of diamonds. Before we talk about this as a class, I'd like you guys to work it out in your group. So hopefully you still have your cards out. See if you can play with the cards and visually find out how many ways you can arrange these different cards. How many orders or sequences can you make? Yeah, of course. So we have 3 cards. The king of hearts, the king of clubs, and the king of diamonds. Okay. For a little bit of clarification,
Okay, you prepare. I will come back to school. Okay.
someone tell me what's one order you can make for the king of hearts, king of clubs, and king of diamonds?
Lunch with the student.
What's one example? What's one order we can make? Okay. Yeah. Okay. One order is the king of hearts first, and then
But I come
the
back.
king of clubs.
I bring the
Okay.
spoon.
And
Yes.
the king of
I come back
diamonds
in the
third.
afternoon.
This is one order
I have
you
lunch.
can make for the 3 cards.
that's
And I want you guys to find out how many possible orders there are. What is the sample space for this experiment?
Want to use?
Alright, so Look. Okay, I think some of you got the answer pretty quickly, okay. But let's work it out together. Let's see how many orders we can make. Alright, so for me, first, yeah, I heard somebody call it out. What's the total number of orders? Yeah, 6 is correct. Did everybody get 6? Okay, good. Alright, then we can progress. So, we know the total number of outcomes, but one thing that a sample space is really used for is actually visualizing the way we can arrange the different cards. Alright, so let's imagine, we know we have 3 possible spaces to put the 3 cards. So, we have to start somewhere. Let's pick a card for the first space. What card do you want to use first? The King of Hearts, of course. And okay, so let's imagine we choose the King of Hearts as the first card. Now we're left with how many cards? 2 cards. And those 2 cards are the king of clubs, and the king of diamonds. Correct. So, we chose the king of hearts first. Imagine for a minute we chose the king of clubs second. If we did that, how many more options would we have for the final slot? We started with one card, the king of hearts. We moved on to the king of clubs. And now our final, we're only left with one outcome, which is the king of diamonds. Correct. And actually, here you can see the original order that we chose. King of hearts, king of clubs, king of diamonds. But imagine we had chosen the king of hearts, followed by the king of diamonds. Now, what option would we be left with following that? The king of clubs, correct. Okay, but we started with the king of hearts, and that's only one of our three cards, so we need to start with another card next. What card do you guys want to start with next? King of diamonds. Had we chosen the king of diamonds first, we would have two more options, which are hearts and clubs, right? Now let's imagine we used the king of diamonds first, we chose the king of hearts second, and then our final choice would have to be clubs, right? And if we'd chosen clubs second, we'd only be left with the king of hearts, right? Okay, and now our third example will be just like these, except we're going to start with which card? The king of clubs, thank you. Okay, if we start with the king of clubs, we have two options left to us again, which are the king of hearts and the king of diamonds. We could have gone king of clubs, king of hearts, followed by king of diamonds. Or we could have done king of clubs, king of diamonds, followed by king of hearts. All right. Now, let's count the options that you guys so quickly figured out a minute ago. We have 1, 2, 3, 4, 5, 6. Yeah, good job guys, you are correct. There are 6 possible ways to arrange these 3 cards. Does anybody know what this is called? This diagram that we just drew? A tree, yeah, it's called a tree diagram, that's right. Tree diagrams are really nice when you're first learning sample spaces, and also just for systematically listing the orders. They're good for when you're really interested in what the actual arrangements are. Maybe you're not as interested or equally interested in the total number of outcomes. Okay? But sometimes we don't want to count the total number of outcomes by hand because it can take a really long time. And that's why we have a nice principle called the fundamental counting principle, which states that the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes for each event. Okay, that's a long and confusing definition, but let's look at it more visually here. If we have 3 spaces where we can put cards, let's take the first space here. We have 3 cards and 1 space. So how many possible cards can I put in the first space? How many choices do I have? 3 choices. Once I've chosen a card for the first space, I move to the second. And how many choices do I have now? 2. Right. Now I've chosen 1 card for the first space, 1 card for the second space, so I'm left with just 1. According to the fundamental counting principle, what should I do to each of these boxes? I should, yes, multiply them. Thank you. Okay. So, what happens? When I multiply the 3 boxes, I get 3 times 2 is 6, times 1 is 6. And there's our answer. We didn't have to count anything, we didn't have to draw anything, we just multiplied the number of options in each space. This is really good when you want to solve more difficult problems. The fundamental counting principle makes life easy, and to see how, I want you guys to consider 2 more examples. With your group, please discuss and solve how many ways can you arrange all 4 kings? And then, how many ways can you arrange the whole deck? You can try to use a tree diagram or visualization here. Or if you're comfortable, you can go straight to the fundamental counting principle. I'll give you guys a minute to think about that. Hello? Alright guys, so you've had some time to think about it. Does anybody know how many ways you can arrange all 4 kings? 24 ways. How did you figure that? 4 times 3 times 2 times 1. Correct. That's right. You use the fundamental counting principle. Did anybody figure out the second problem? How about the whole deck? 52. What? What? Factorial. I don't know that word. Okay. So, 52 factorial. Yes? 52 times 51. I think it might be a bit too small. Actually, the number of ways you can arrange the whole deck is tremendous. Does anybody actually have an estimate for that number? Any guess? Do you think it's more or less than 1 billion? Do you think it's more or less than 1 trillion? Less than 1 trillion? So some people say less than 1 trillion, some people say more than 1 trillion. Some people say a lot more, and those people are correct. The number of ways to arrange the entire deck is 52 factorial. It's 8 with 67 zeros after it. So it's like trillion, 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 trillion ways. It's a lot of ways, yeah, to arrange those cards. So somebody knew the vocabulary a little bit ahead of the game. Factorial, as you put it, is how we solve this problem. This is what the fundamental counting principle says. The basic idea is factorial. If I want to know the number of ways I can arrange the kings, all 4 kings, then I'm looking at 4 factorial. If I want to arrange 3 kings, what factorial am I looking at? 3 factorial. If I want to arrange the entire deck, which factorial am I looking at? 52 factorial, that's right. Okay, now it's your turn. You guys are going to solve some problems. I want you guys to work on them by yourself. And then you're going to discuss it with the person next to you. So I'll give you guys about 5 minutes to solve these problems. And then to discuss them with the person next to you. And I'm most interested in how you solve the problems. This is what I want you to talk about with your partner. How did you solve these problems? shoe pairs. Okay, guys, I'm going to cut you off there. I hope you had time to think about the problems and discuss. Okay, so let's start with the first problem. Number one, the shoe manufacturer, he's got brown and black shoes in 9 different sizes. So, how many shoes does the shoe manufacturer make? 72. Okay, what's your name? Okay, would you mind explaining how you got that?
There are 2 types of shoes in 9 different sizes, so there are 2 spaces. So 9 times 8, 72.
Okay, so you said there's two possible spaces. Okay, and then you said it's 9 times 2. Okay, so the options in the first space are 9. What are those options? Brown and black. Okay, so the sizes. Yes, exactly. Okay, so the first option is the sizes. Right. We have 9 different sizes. Okay, so in the first space, the first thing you have to do is choose the sizes. Okay, and now we have the second space. So which options are left to us? Hearing a lot of different numbers. Yeah.
Size 9, size 8,
Yes, okay, we had a lot of different answers for this one, but the basic idea is that with the first space, right, first we have to choose the shoe size, and we have 9 different options for the shoe sizes, followed by the 2 colors. So we only have 2 different options for the second space. Okay, now we can do the tree diagram, or we can use the fundamental counting principle, which would tell us that the total number of outcomes is 18. Yes. Yes. So we've got 18. Okay. Thank you very much. Okay, and how about the second problem? 9.
English program.
Did you say 9 factorial?
Sa Facebook page. Type mo lang EPMEP. Isan. Oh. Malabas mo.
Basically 3 years. I did a total of 23 years of the stuff in a line. I think still the next 3 years is a baseline or a line up. So no 2 figures can share the 6 part in line up. So it means it's full already. Line the 9 figures in line up.
Okay, so we have the 9 players in the lineup. So 9 spaces. So how many options are there in the first space that I can fill? Yes. Right. Followed by 8. Yeah. Great. And then 7, 6, 5, 4, 3, 2, and 1. 5, 6. What do we call this? 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 9 factorial. Yes. Great. Thank you. And did anybody get the total outcome for that? $320,800. Let me check that. 380. 362880. Oh, I'm sorry. That is correct. Yes. 362880. You are correct. Okay, a lot of possible outcomes. Prize? You want a prize? Yeah, okay, just hold on a second. Sorry, maybe after. I'll give you my my custard cake at the end of this. Okay, let's move on to number 3. How many possible arrangements are there for 5 cards when you pull them randomly from the top of the deck? 120. Why do you say that? 5 factorial. That's right. Congratulations, group in the back. You are correct. This example is just like the example we did originally with the 4 kings. If we have 4 kings, the first slot has 4 choices, followed by 3 times 2 times 1, that's 4 factorial. When there's 5 kings, it simply becomes 5 factorial. Okay, we need to move on. Does anybody have any questions before I cut you loose and make you solve some problems? Not so far. Good. That's just because you want to win all the prizes. Okay. We're going to do some dictation now. You guys are going to practice speaking the problems, memorizing them, and we're going to test your understanding of the concepts and the vocabulary. Okay. So, I want you to get into your groups that you initially played the card games with. Can you remember your groups for the card games? One more time, guys. Okay. There are math problems all around the room. Each group needs to send one person from their group to come to one of the math problems posted on the wall. You, that person, will read the math problem, memorize the entire problem, come back to your group as quickly as you can because it's a race. Dictate the problem to your group. Your group will then do what? Correct. Your group will then solve the problem. So, when you solve this problem, group, you need to be listening for the important information. What? What? Oh my Buddha. What have you done? I know he's not getting a prize now. You were right. They do cheat. Okay, well, honestly, we're all adults here. I think the rules are, as Jack Sparrow once said, it's what a man can do in this life. So I'm gonna let you guys get to it. Please nominate one person to read the first problem and dictate it to your group. Know that there are 3 problems, so you're going to need 3 total people in the end. All right, and let's see who can solve the problems.
I think you're looking kind of blurry, kind of teary-eyed, and I think it's time for you to take a break.
Yeah.
Come back in about 15 minutes. We're going to plug this laptop.
Yay!